Today we're going to continue with section 2.5, which is transformations of functions. So just like yesterday, we are going to use vertical and horizontal shifts to graph functions. We're going to look at reflections, talk about stretching and shrinking, as well as just involving multiple types of transformations within one problem. All right, so let's take a look at this example here. So I've really just given us the transformed graph. And so we still have to identify the parent function first. So we'll do that. We'll graph the parent function, and then we will then start graphing this g of x, and we're going to make a table throughout. So we are dealing with trying to figure out a parent function. So it's everything that we want to get rid of all of the extra bits. So notice that I see a cubed root. I see a negative x underneath that cubed root, and then I see plus 2 at the end. So ignoring the plus 2, ignoring the negative underneath it, hopefully we're okay with my parent function just being the cubed root of x. Okay, so that's what I want us to graph first. So when we're making a table of values, I have to think about, okay, well, what numbers are going to go in for x that are perfect cubes? So it might help if we actually work backwards. And normally in our table, we kind of plug in the numbers like -2 up through +2 for x. Well, those are what I actually want my y values to be. And so then if I work backwards and I then cube these numbers, it's going to get me the value of what I really plugged in for x to then get the answers that I got. So if I cubed -2, I know that it was because I plugged -8 in underneath the cubed root. And if I cubed -1, I know that it was -1 that I put into my original function to get -1. 0 is what I had to plug in to get 0. 1 is what I had to plug in order to get 1. And 8 is what I had to plug in order to get 2. So I'm going to plot these points. So -8, -2, -1, -1, 0, 0, 1, 1, and then 8, 2. So this, remember, it looks like a cubic function, but it's turned on this side. So this is my f of x function. And now that I have my original parent function, I'm going to continue building off this table to now actually graph this g of x function. So because I see a reflection, the negative is underneath that cubed root. So that means that that negative is going to be affecting the values of x. So I want to go to the very first column, and I essentially want to multiply everything by -1. So -8 times -1 is +8. -1 times -1 is +1. 0 times anything is 0. 1 times -1 is -1. 8 times -1 is -8. Okay, the only other transformation that I have is the adding of 2. And because that is outside of the cube's root, that's essentially dealing with your y values. So it's going to deal with that second column, the f of x column. I'm going to add 2. Remember, I keep the sign the same when I'm dealing with that, in this case, vertical shift. So -2, I'm adding 2, I get 0. -1 plus 2, I get 1. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. So my g of x function are these ordered pairs right here. 8, 0, 1, 1, 0, 2, -1, 3, and -8, 4. So I'm going to plot those points. So we've got 8, 0. We've got 1, 1. We've got 0, 2. -1, 3. And -8, 4. So when I connect those points, this is my g of x function. So notice that it is turned the other way, and that's because when we had the negative sign underneath and it was dealing with the x, it's because we were reflecting over the y-axis. And notice how it is shifted up because we had that vertical shift where we had to add on 2. Let's try another example. Okay, here's my g of x function. We've got -2 times the quantity x plus 2 squared plus 1. So if I strip down all the extra bits and I just want to figure out what the parent function is, f of x equals, well, notice that this is a squared term. So x squared is my parent function. So I'm going to start off by making a table. And remember, because we're dealing with a squared term, we should be creating a shape that is a U. So I can square negative numbers, I can square 0, I can square positive numbers. So that would give me 4, 1, 0, 1, and 4. So here are the points that I'm going to plot. It's going to form that U. So negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. And so there's my f of x function. All right, so if I look at the g of x function, there happens to be 3 different things that are happening. We got these 3 numbers here. Okay, technically it's 4 because it's not only a 2 out in front, which is going to make our term stretch, or our function stretch, but it also has a negative, so we're going to be reflecting as well. But we can actually do that together as one step. All right, and I'm going to start there. I'm going to start with that multiplication. And because that is happening outside of my squared parentheses, I know that it's going to be affecting the f of x column. So I really want to take negative 2 and multiply that by the f of x column. So 4 times negative 2 is negative 8. 1 times negative 2 is negative 2. 0 times anything is 0. 1 times negative 2 is negative 2. 4 times negative 2 is negative 8. All right, now I'm going to deal with my horizontal and vertical shifts. So the fact that inside that parenthesis I see a +2, that really means that we want to move in the opposite direction. So my first column of x, I actually want to subtract 2 from all of those. So when I subtract 2, I'm going to have negative 2 minus 2, so that's negative 4. Negative 1 minus 2 is negative 3. 0 minus 2 is negative 2. 1 minus 2 is negative 1. 2 minus 2 is going to give me 0. The last thing we have to do is we have to add on the 1. And because it happened outside, that means that's dealing with the y's. So our latest column with the y's was this negative 2 f of x column. I want to add 1 onto each of those numbers. So negative 8, I'm adding 1, so I'll get negative 7. Negative 2 plus 1 is negative 1. 0 plus 1 is 1. Negative 2 plus 1 is going to give us negative 1. And then negative 8 plus 1 is negative 7. So that gives us the ordered pairs that are going to be my g of x function. And we'll know that we did it correctly if we get another shape like a u. So we've got negative 4, negative 7, negative 3, negative 1, negative 2, positive 1, negative 1, negative 1, and 0, negative 7. So notice that when I connect those points, we've got that reflection. So notice that we started with the u up, now the u is down. Notice that our points, it takes longer to get to all of the new points that I have on my g of x function, and that's because we're stretching it by 2. And then we obviously shift it a little bit. So we move 2 to the left and 1 up. Okay, one more example together. We're going to graph g of x equals 1/2 times the square root of x minus 2, and then minus 3. So once again, if I want to identify that parent function, I'm stripping away all the extra stuff, and it looks like that we are dealing with a square root of x. So if I start making a table, I want to be putting in numbers that are going to make my square root have real numbers, and the easiest numbers would be perfect square numbers. So I start with 0, 1's a perfect square, 4 is a perfect square, 9 is a perfect square. That gives me 0, 1, 2, and 3. So I'm going to plot those points to create this function. So we've got 0, 0, we got 1, 1, 4, 2, and 9, 3. So here is my f of x function. Now we want to move on to be able to create our function for g of x. So I see 1, 2, 3 different transformations. Okay, I want to start with the multiplication. So it looks like I've got a 1/2 on the outside. Because it is on the outside, that means that it's going to be multiplied by the f of x column. Because if it's outside, it's dealing with the y's. So 0 times a half is 0. 1 times a half is a half. 2 times a half is 1. 3 times 1/2 is 3.5 or 3/2 or 1.5. All right. I want to look at the number that is underneath that radical that is dealing with the x's, but remember I want to do the opposite. So instead of subtracting 2 from the x column, I'm adding 2. So 0 plus 2 is 2, 1 plus 2 is 3, 4 plus 2 is 6, 9 plus 2 is 11. And then finally, we've got our 3. Because it is being subtracted outside, that's dealing with our y's. The latest column with our y was this negative 1/2, or 1/2 times f of x. So I'm going to take that column and I'm going to subtract 3 from it. So 0 minus 3 is negative 3. 1/2 minus 3 is negative 2.5. 1 minus 3 is negative 2. 1.5 minus 3 is negative 1.5. So it looks like my ordered pairs are 2, negative 3, 3, negative 2.5, 6, negative 2, and 11, negative 1.5. So I'm going to plot those. So we got 2, negative 3. We've got 3, negative 2.5, 6, negative 2, and 11, negative 1.5. So there is my g of x. Okay, so notice that it took us down and over to the side, and we are dealing with 3 different transformations here. Okay, now it's your turn. So go ahead, pause the video, try to see if you can identify the parent function and then graph the g of x function on the same graph as well. Okay, so hopefully you should have come up with the fact that the parent function was the absolute value of x. And then we are dealing with 3 transformations. We've got a reflection, and we've got a horizontal and a vertical shift. So here were the ordered pairs that you should have gotten for the g of x. Hopefully that went well. So that's us using all of our different transformations in order to then graph not only our parent function, but that new function.